Hey Jeff, how do you do, sir?
Good. How are you all?
Very good. I see
Great.
Rick online, so is it Rick Michaels?
Go ahead. Stay.
I'm going to assume so.
Yes,
Hey,
yes, it's me.
how do you do?
Hey, how's it
Good.
going?
Very good. Good to see you again.
Thanks. Same here.
And Luke, I don't recall if Luke has joined us in the past, but welcome.
I was just typing.
Very good. All right. Well, today we've got two chapters planned, and then we get into a cadence of just doing one chapter per meeting. Originally I was anticipating two chapters per meeting in order to to get through the whole book in about 6 weeks, and then realized that's probably too fast of a pace. So we'll slow it down after this one. But this one, these two chapters actually seem to do pretty well together. So chapter 7 is all about security. Chapter 8 is a catalog of patterns, a very small catalog of patterns. There's certainly a lot more patterns in this than that I use on a day-to-day basis, but these are the ones that I think are a good introduction that help people kind of get a feel for how you can model systems based on these concepts. But yeah, it actually kind of occurred to me that maybe I could have said that there's a set of security patterns. And the reason that I didn't go that direction was that I realized there needed to be a little bit of support within underlying frameworks and libraries that implement historical modeling in order to really support those patterns. So it's not just patterns that then you can build applications on top of, but actual security support. So let's dive right into to security, and I'll kind of seed the conversation by talking a bit about authorization rules. So this is a twist on the way that we do a lot of authorization in distributed applications. We tend to do role-based security, where one authority grants everybody who logs in some set of permissions, and that set of permissions is carried along with their token as a claim. And now you go over to some other application, you say, I am allowed to do this. That that authority said so, and here's these the claim signed with their signature. Verify, yes, I allow you in. And so one of the issues with that is that it's extremely centralized. There is one central authority that is able to give you those permissions. And one of the fallacies of distributed computing is that there is one administrator. And so that would be the person or group of people, so the authority to grant you those permissions. And certainly as we get into distributed systems, but then even as we kind of go beyond and we talk about multiple business units within an organization, multiple organizations, and we want to collaborate, we can't elect one central authority to grant everybody permissions, and so you have to have a distributed way of assigning permissions. So one way to do that is kind of like the OpenID way of you've got something like they actually call it an authority URL, an authority URI, some identifier of an authority, and then a scope or a permission within that that realm of scopes that that authority can grant. And then you can have several of these living within one token, but that's still not quite the world that I envision here. So here somebody should be able to create an entity. They should be able to create a space Like maybe it's a blog, maybe it's a discussion forum, maybe it's a discuss or a Discord server, and then have permissions to invite people to that server. But it should be such that somebody else has different permissions on a different thing, and all these permissions are able to live within the same space. And so, kind of bringing that back to authorization rules. The idea here is that when I tell you that I want to do a thing, it's up to you as the individual node, as the client of that information, not the central server, not the authority, but as the client to say, well, do I trust that this person is authorized to do this thing, and that trust is derived from the model itself. It's derived from the information that you already have. Well, okay, I know that this person is the one who created this Discord server, so therefore they have the authority to invite people to join it, that kind of thing. So it's a sort of the sort of rule that you run on the client, not that you run on the server. And so that's a different approach, and and kind of the reason for that approach. So with that, I'll open the discussion. Was that something that that you found surprising, or was it kind of similar to something you'd seen in the past?
Michael, with these public keys that we use as identities of users, how can we go ahead to imagine we are in a mobile environment? So user has a mobile device. The moment that he loses that device, his ID is stored on the device. Then we have to cancel that ID because the device is lost, is stolen. So we should be able to allow a user on a particular device, but that means that every combination user device needs to have a certain ID.
So there
it gets it gets complicated.
The set of patterns, if you do follow it down that path, does get rather complicated. You can kind of draw some inspiration from one of my least favorite places to draw inspiration, but yet I do all the time, from the blockchain world. And so you see that a wallet is identified by a public key, and a wallet is basically the authority to spend currency that wallet had received. So you actually have that exact problem. If you lose control of the private key, then somebody else can drain that wallet, act on your behalf. If you just lose the private key and not lose control of it, so somebody else has it, but you yourself don't have it anymore, then that that money is locked up. Everybody can see what's in that wallet, which is one of the weird things. We can talk about blockchain some other time. But when somebody says, "Hey, we can't see what's inside of this this private wallet," like, yeah, you can. It's a public record. Of course you can. But anyway, so you've got those two problems, and basically the way that that blockchain handles that is that you've got ways of saving your private key in several different places and trying to keep them protected, and then it's really the fact that the wallet is not the individual. So throughout the book, I do talk about the public key being an identity for the individual, and I don't really talk about kind of a separation of as an individual, as a human, I've got several different identities within the system, and each one has its own public key. So I think when we get into the actual implementation based on these rules, we'll start to find that we really gravitate toward more of that one degree of separation between the identity that we have in the model and our actual identities. And then
because actually we should have something like the classic tokens, where every device gets a token, and that gets changed regularly. So you lose a device, the token is not renewed, and you can just continue on another device with your own ID.
Yeah, I actually had a question about that, like token rotation and things like that. And you mentioned in the book a few times about, make sure that the keys you use are at least enough bits that they're not going to be cracked in the near future. But, what if you're rotating, tokens for users or systems that you want to be able to connect to your fact database? How are you dealing with that kind of stuff? It seems like eventually there's going to be some master key somewhere, and it's like, don't lose that. It's sort of like CAs. It's like it's turtles all the way down. At some point, there's like, if somebody gets to that root CA, we're all screwed. But like, what are your suggestions or recommendations on how to make sure that you're not, like say stuck with a bad decision or something, or unable to rotate keys or things like that?
Yeah, in the world of PKI, you've got validity dates. So a root CA certificate is going to only be valid up to a certain point. You do also have a standard for revocation, although nowadays most browsers don't actually honor that standard, and there's really good reasons why. Basically, what you're asking them to do is a distributed delete. And that's hard. As we know. So the solutions, I would say, are related to the solutions that we're seeing there. One, associate identities with the clock if that's at all possible within your system. So I always keep on going back to this period pattern. Have some sort of clock in the system. And so if you grant everybody by some means they're able to create a brand new identity, a brand new key pair to move on over to the next clock tick. And then that other one will age out, and there won't be any new data being collected over there. And then when the day comes that those keys are hacked, well, they've got access to history. Hopefully that history is old enough that its value has degraded, but they won't be able to do anything new with it because nobody's paying attention to that clock tick anymore. Now that's kind of a hard thing to do. So the other key piece of this is to have some sort of a key store that's separate from the device. And this kind of answers some of the questions that Jan was starting with there. What if you lose your device? A mobile device, if we wanted to be completely paranoid, the mobile device should have its own key store, and the private key should never leave that device. But then that means that you couldn't act as that same identity on a different device. Because the private key is not there, and you can't sign any documents on the new one. So if you can extend your trust just far enough to be able to put your private key into a key store. Now that is a central server, so it's not that you are using the distributed network itself as a key store. Because you have to be able to flow through untrusted nodes and all that stuff, and not gonna do that with a key store. So key stores are central static databases, and so if you authenticate with that key store, so now you can just use a short-lived token, like an OpenID Connect kind of a thing. Authenticate with that key store, and then use that bearer token every time you are creating a new fact within the system. And then that key store says, well, okay, I trust that you're authenticated. I will sign this because I've got possession of your private key. Then now you've got something external to the user that can actually participate in that rolling forward to the next clock tick if you need to.
So it sounds like, well, I don't know, clarify if I've got this wrong, but it sounds like then the identity or the user fact that you would put in, it would just be, I don't know, like a GUID or a username or something. And then you could associate that with different, like maybe, and this is where you might use the period pattern where the user itself maybe isn't under the period pattern, but then you could associate those different bearer tokens with that or a signature or something that's their current identity, and then you could use those under the period pattern to say what is the current, available key for this, or there could be more than one, right? I mean, a lot of systems, like in GitHub, you do this all the time. You create personal access tokens, and you can have a bunch of them for, if you're interacting with different repositories and different organizations or things like that. So that helps. That really helps. It really is funny how you mentioned that too. The period pattern keeps cropping up, and it makes a lot of sense that things need to be thought of temporally, because we do live in a 4-dimensional reality, and here we are trying to model everything in 2-dimensional relational databases all the time. So yeah, that's really, really good, insightful stuff. Thank you.
Cool. Yeah. Welcome.
Can you hear me?
Yes.
I don't. Yes. I have a question, because we are able to encrypt fact graph, yes, with this rotation keys, for example, and it's encrypted. Where is this link between key which was used to encrypt those facts? Right. Because you said that for each period we may, for example, rotate those keys. Mm-hmm. And where this information, this link, where is it that connects it with this keyword which was used?
Mm-hmm. Yeah. So there's a couple of important things there. So first of all, the thing that you're encrypting is not the graph as a whole, and that's because in order for nodes to be able to participate in the running queries and sharing information, even if they're untrusted and they themselves can't see what's inside of the facts, they still need to know the relationships between them. So
okay, I understand that.
Yeah. Okay. Good. And then the data itself is encrypted using symmetric keys. So AES, for example, and that AES key is not stored in the clear in any place. It is stored in another fact that is signed using, or that is encrypted using one person's public key. So only they, with their private key, can decrypt it, and now they've got that AES key, and they can decrypt the other facts. So it's a bit of an indirect concept there, but that's the same pattern that you would see with using a session key in order to decrypt traffic in like a TLS connection. Is that you in the case of TLS, you'll use Diffie-Hellman in order to generate a new symmetric key, but then now that symmetric key is used during the communication. But yeah, in this case, if you wanted to, since you want to persist that data, you persist it by encrypting it using somebody else's public key, and now only they can decrypt that session key. So
basically, I can store this AES key inside a fact and encrypt it with my private key, and after the decryption, I can use this key to decrypt all the sensitive data inside the fact graph. Yes. For this period, for example. So under the period, I have a fact where I can store this key. to decrypt it later.
Yes, yeah, and that fact where you store that key, that's basically like an invitation to a shared space. So, so like you've got a discussion forum where you want to keep things private. So you will send somebody an invitation to join that discussion forum. Basically, that invitation is a fact containing the session key, the shared key for that for all of the information in that discussion forum, encrypted using their public key. And so now they can decrypt it. But then that same key, when you send an invitation to somebody else, you encrypt it with their public key. So they've got this the shared key. And so that, coming back to when you start that discussion forum, you yourself have to make up a key. So you generate a random number, you encrypt it using your public key, and you store that in a fact. And now you can decrypt it later. You can come back, log back in, and get access to that key again. So you give yourself an invitation to the same space.
So the periods are going to let you, basically, like you said, you could rotate those as well.
Yeah.
But if you rotate them, if you don't have access to the old key anymore, you won't have access to the old stuff anymore. Mm-hmm. But so you could still practice. I'm imagining this is how Keybase works, and I don't know if Discord is as encrypted under the covers, but I'm pretty sure this is how Keybase works. Something along these lines, because you can create. It's like Slack, but it's open source, and it's using blockchain technology under the covers because, blockchain. Of course, they just got bought out by Zoom, which now makes me suspect of them. But anyway, you can invite people to channels, and everybody has keys, and then you make public. You put out all of the things you own online to prove your identity. So I own this website, I own this GitHub repo, I own this, that, and the other. Mm-hmm. So it's actually a really cool identity system. But my point is, I'm pretty sure they're not using the same key forever for everything in a channel. Mm-hmm. That just seems like that would be foolish to just keep using the same key over and over and over again for a really long time. So this is really helpful. You're giving us some good mental space for how to do key management and encryption for all of these, hashes and stuff that we're going to need to be dealing with here. So yeah, it's great.
Yep. And it's funny you say it would be foolish to use the same key for a long period of time. Well, that's basically Snapchat. Or at least they used to be like that. They might have gotten better, but
yeah,
I'm not going to return to the platform to find out.
Yeah, right, right. Yep.
Okay, so the patterns then that we get into based on key management and identity management, they do kind of just scratch the surface, I would say. So the book doesn't go into all of the different things that you would have to do in order to really solve the problem, but it just kind of gives you the space of problems and a set of tools that you can start with. I think there's a lot more research, a lot more support, a lot more iteration that can be done on this problem. This is one of those areas where I don't pretend to have the full answers yet, but hopefully we will get there. But yeah, if you take a look at coming back to blockchain, so blockchain does keep the separation between the user's identity and their wallet, so people can roll from their funds from one wallet to the next over time, and they do, in order to now age out those private keys just in case those get hacked. But blockchain is also based on the security of the hash. So if a hash of an old block is ever found, if you find a collision, so we're going to find a new block some point in history that has the same hash as an old one, then I could convince other people that this brand new history here, starting with this new block that I've discovered, replaces the old history. It would not be an easy task, but if you were able to sow enough confusion, you could start to get, half of the machines in the world thinking that this was history and not that. And that would be a kind of a permanent break of that chain. So it's not just. I mean, you have to think about all of the different facets of encryption, and any one of them, if it's broken at some point in the future, is a vector, and you have to. You think about this stuff too much, and you start to get kind of paranoid, and that might not be a bad thing. Quantum cryptography or quantum computers are coming, and they, Shor's algorithm is real. So it will break elliptic curve first, and then RSA, and then also give us a tool to start attacking symmetric algorithms as well. It might make AES a little bit easier to crack, or SHA a little bit easier to find collisions.
Oh boy.
Yeah. But yeah, that's why I'm keeping an eye on the post-quantum cryptography competition that's running right now.
Oh, interesting. I didn't know about that. Well, and also I think, we need to be thinking about strategies for dealing with that. I mean, to me, that's what software architecture is all about. It's seeing what's coming and then designing for volatility. Mm-hmm. And most people design for features. And when you design for features, you're dead on arrival. And yet that's how most software is built. And maybe eventually they spend enough money and have enough death marches that they get somewhere, or they get lucky. But most software projects, they're dying because they're struggling, because they don't understand that your real job is to isolate volatility so that when you have big changes, they don't ripple through your whole system. Mm-hmm. So this is a great example of that kind of volatility that, remember long-term capital management back in the 90s, they went bust and their excuse was, well, this was a 10 sigma event. Well, no, you had the wrong distribution in mind. It was a fat-tailed distribution, not a normal distribution. So, somebody should have gone to jail, but they just threw up the excuse, well, it's a 10 sigma event. And it's like, well, life is not normal, like a Gaussian bell curve. Life is fat-tailed. And in situations like this, one addition to your sample can take credit for half of the variation, right? And like shift the mean by orders of magnitude. So this is one of those examples. This is a great example, because when quantum comes, the people that are ready are going to thrive, and the people who are not ready are going to be caught in big trouble. This will be way worse than a Y2K problem. Way worse. But people said, oh, that'll never happen again. As soon as they say that, you have to say, really? Mm-hmm. You're wrong when you predicted that last time. Anyway. So yeah, I'm glad you're bringing this up. It's really, really helpful.
Cool. Yeah, and it's top of mind because actually I just refreshed my Pluralsight course on cryptography, so that's going to be hitting the catalog soon.
Nice pitch. I'll have. Please tell us when that's ready. That sounds like fun.
Cool. All right. So yeah, let's switch gears and start talking some Chapter 8 stuff. So this is the obligatory catalog of patterns, a la Gang of Four. And even though we've seen catalogs of patterns embedded in books many times before, I felt this was important to go ahead and put this in here. So yeah, it basically breaks it into two different sets of patterns, and of course, any catalog of pattern has families of patterns. So I talk about the structural and the workflow patterns. So structural are basically my giving back to you your CRUD operations. Since I was so mean and I took them away in the rest of the book, I'm like, okay, you can update a thing, you can delete a thing, you just have to do it differently. So yeah, there's just a pattern way of accomplishing these things, and I think the one that really kind of stands out among the structural patterns is the mutable property. So when I first described this pattern to a person who's now become a good friend, but when we first met and we were just kind of chatting around, this was during a speaker's dinner at a conference, just chatting around the table. Hey, what you working on? Well, this thing over here, and this is how you change data in this thing. And he said, "Oh, that's a vector clock." And at that time, I hadn't learned about vector clocks, and so I looked it up. Sure enough, that's a vector clock, with some differences, but yeah, close enough. So yeah, the idea of the mutable property is that now you can detect when a conflict happens, and I'll put conflict in scare quotes there because it's not really a conflict; it's a concurrent change. Two people change the same property concurrently, without knowledge of one another. Concurrently doesn't necessarily mean exactly at the same time. It's just I made my change before I knew about yours, and vice versa. So when that happens, you can detect that by just evaluating the DAG, the directed acyclic graph, and seeing that there's more than one leaf of this particular tree here. So therefore, there's more than one candidate version. So have you been able to apply this pattern in any of the systems that you've worked on, or have you thought of ways that you could?
No, I think I really appreciate the patterns chapters. They make things very practical. There's a lot of heady stuff that's like you got to sink your teeth into, and it's like you're just getting your feet wet, and it's like you're just over Marianas Trench. Like it's going to go real deep. So you got it takes a while. But the patterns I felt like really make things accessible, pretty, like especially for people who are familiar with other pattern libraries. So yeah, I mean the entity idea, and I think that of course in line with references. You can start to think about building up aggregates based on facts. Mm-hmm. And I still see a lot of not similarities, but like if you have any history with event sourcing, I feel like in some ways this might make it easier to grasp this, but it also might in some ways steer you the wrong way. So you have to be careful. But this is one of the areas where, a lot of people that are doing aggregates, they're doing them with event sourcing, mm-hmm. and kind of the paradigm seems, somewhat similar. So yeah, that was really helpful. And I can definitely see places where it's useful cropping up here and there. Mm-hmm. Yeah. I mean, things change, right?
Yeah.
So
you have to be able to capture those.
Yeah.
Yeah. There was a system that I had worked on. I don't know if I mentioned it by name in the book because I asked for it, but did not receive permission to use the name in the book. But this was a system for keeping track of law enforcement cases. So you would have people from several different areas within law enforcement and investigation, forensics, all entering information about these cases, and there was one group of administrators that were there to make sure that the information that went in was relevant, was the sort of thing that could be shared, that you weren't accidentally putting in certainly this was all based on PII. This information already contained PII. That was kind of the whole point. It was to identify people, but there's some personal information that they did not want to be disseminating. So that meant that there was a long period of time between somebody entering a piece of information and an administrator approving it. And so during that time, other people who came to the site and looked up the case would still see the information before they had made that entry. And so during that period of time, even though this is a database, this is a website, so everybody is all connected to the same system at the same time. It's not like a disconnected mobile app. Even so, that meant that they could make a concurrent change. They could make a change without knowledge of something that somebody had already put in, but just was not yet approved. And so for this system, we came up with a database. So kind of going into the database patterns in Chapter 10, we applied those patterns, but this was not in a application agnostic way. We applied the patterns for the actual application database, and kept track of predecessors within that database. So somebody entered some information. It was an insert, and that meant the information that they were overwriting was still there. And then we could do a historical query to find, first of all, filter based on has an administrator approved this change, and then do the further filter on has it been replaced by some successor. And then there we would have those situations where we would come back with more than one record, and we would have to display the merge on the web page, and then somehow give the administrator the ability to merge concurrent changes together. So yeah, these patterns definitely came to light even without an occasionally connected mobile application or something that we would normally consider to be truly distributed, just based on the ability of making concurrent changes.
Michael, on page 264. It's the second paragraph. There is a disappointing sentence. I didn't thought about that, but on reading it, the mutable property fact should not contain any auditing information. Yeah, because the result would be an unnecessary merge between similar changes. And that's a pity.
Yeah.
I was thinking, what would be a solution is that to a fact now, everything that is in a fact determines its identity. Yeah. Now we could add some metadata to a fact. For example, a timestamp and the originator from the fact. Metadata that's not part of the identity of the fact. It should be a collection, because imagine that we have concurrent changes. Michael changed something, Jeff changed something, so we have two facts which are the same fact. Then in my single fact, I should have Michael and Jeff as originator and two timestamps. Would that be a solution, or do you have something else as a solution?
That would be a solution. Yes. And
in
fact,
or better.
And you'd put that in the fact. You're not talking about metadata as a separate thing. You're just saying that the identity is the content. So help me out here. I'm trying to make sure.
So this is a separate thing. Yes, this is
outside the fact.
Yeah, outside the fact.
And does this breed some location dependence, or am I missing something? Maybe it doesn't. I don't know.
It does if you are okay. So, I've actually implemented exactly this solution in Janaga. So, so in Janaga you've got the fact table, and then you've got an envelope table, and so envelopes are really just capturing that some authority has signed. So that's what contains the digital signature of that fact from the author. So kind of bringing it back to the previous chapter. And so that envelope, not only has the signature, but in order to really know how to validate that signature, it refers to the public key of the user that signed it, and it also contains the date at which it was signed. So that's kind of where, Jeff, where you don't quite have the location dependence, because that's the date at which it was signed, not the date at which this particular node learned about this fact.
Got it.
Now, where you saw the bit of hesitation is that indeed in this table in Janaga, I also capture something called date learned. So this node knows what date it learned about the fact, and that is strictly for diagnostics. It's that is not exposed through the API, so you can't make a programmatic decision based on that information.
Kind of like the IDs, if you're putting them in a relational table, those need to be kept and only the hashes emerge.
Right.
So that means, so just to continue along with what Jan was saying, you could add a collection of authors and timestamps as well, I suppose, if you wanted to capture that information. That would not be part of the fact,
right.
or would, I mean, how useful is it if it's like what you said for date learned, if it's only for diagnostics on this node rather than being useful for other nodes?
Yeah, it's also useful when you have to go with a pattern like bookmarks to download a set of changes that have occurred since last time. So now, once you've established, I'm talking to the same node that I was before, and I've received this bookmark from that one, and so there's some monotonically increasing thing just on that location that can keep track of what I need to know about now. It's helpful in that regard.
Yeah, interesting.
Yeah. But it would also be useful in conflict resolution. If you make a change and I make a change, and then Michael sees, there are two concurrent changes, then he will say, okay, probably Jeff is the most knowledgeable or Jan is the most knowledgeable, so I will probably choose for A or for B.
And I see how it could be useful for that. The thing that concerns me about that is that feels like I'd rather model that in my fact model if that's important. And I'd rather have a way to say someone in this role, they're going to win out in a concurrency race over this other person. That way you're explicitly modeling it instead of making it part of your infrastructure.
Yes, if you want to do it automatically. But here I just want, like on page 264, where Michael wrote, so mutable property should not include the originator of the fact, metadata.
Right.
Well, sometimes you just want to have the mutable property and the rest is not really relevant. But you still want to have the data somewhere.
Mm-hmm.
Yeah, I'm not saying there couldn't be a use case for it, of course, but I think in the vein of what Michael's been saying in the book and in our talks as well, it's like if we can make it explicit in the model, let's do that first. But of course, there's going to be times where there's a good reason not to, and I'm sure there's use cases for what you're describing as well. In fact, one of the things I've been trying to figure out is on one of the pages where you talk about conflict resolution. It's not in the patterns chapter, but it's related to what we're talking about right now. There gets to a point where you have two contact entities that are, or two contact facts that are like you've got Bob, and Robert, and this, you know what I'm talking about. And then you get to the end, and you've got Robert with the old phone number, and you've got Bob, or I'm sorry, or whatever it is, right?
Yeah. Yeah, it's like new name, old phone number, old name, new phone number. Yeah.
Right. Now, if for that mutable property, if it only has a single prior field, you can never bring those together. Now you're going to always have two endless streams of difference, and you're always going to be reconciling the merges. So do you need to make sure that all of your mutable facts can allow more than one prior so that you can actually merge the streams? It seems like that would be the case.
Yes, okay. Absolutely. Yeah, that is.
So to have a single prior does not make sense for a mutable type. You need to because a lot of the queries in the book, it's like and again, I know it's simplified, just forget in the book, but it just says, where exists prior or not, you know what I mean? When it does that thing and it's like you're querying, and then it says, hey, if I'm the one that doesn't have a prior, then I'm the one that's the current one. Mm-hmm. So here would have to be if I'm the one that doesn't have any priors, and maybe that's common.
Yes. In fact, that was a choice. I don't know that I mentioned that explicitly, but a choice in the design of the factual modeling language, that the query syntax is always just equals rather than contains, and that was really just for simplicity. So when you're reading the query, it's always the same thing that you're reading. You don't have to know, oh, this one is a multiple predecessor, so therefore I have to use the contains operator. That one's singular, I have to use equals. Because then it's just a change in operator based on the type, and it's always
I agree
in the same direction.
It's existence, right?
Yeah.
So if there's one at all, then you know that you're not the last in the chain. But allowing for there to be more than one was the thing I was saying. There's got to be the way to merge, and maybe it's in the book and I just missed it and I didn't remember. But I figured that was the case. But thanks for confirming that.
Yeah.
Helpful.
That is
now to come back to page 264, what we could always do is just put the originator and the timestamp in the fact, contrary to what you advise in the book. But if we do that, okay, then it will be two different changes, and we have to merge them. So the history will be recorded anyway.
And then you get a record of who it was who made the decision to do the merge in that particular way. And actually, that kind of model is closer to what you see in Git, because a Git commit also records who did it and when. So a timestamp on their device. And
yes, but Git lets you rebase.
Yeah.
Now, I was going to say, though, actually, that you could do this in a Factstore too. Mm-hmm. But you just have to make sure that you're only working locally as long as you're rebasing. As soon as you start sharing those facts, you're not allowed to rebase. So that's the difference. Because in Git, if I'm a jerk and I go into master and I start fiddling around and rebasing, I can do git push force and screw everybody else and make them have to completely regen the repo, which you could do with the fact model as a Factstore as well.
Sure can.
But when I'm working locally, I'm checking in like crazy, little bits of stuff here and there, here and there, here and there. So I could see there being a way, say in a mobile app or a PWA or something, to be in sort of local like you are with Git. You're just working locally, and you're trying things out and you're doing stuff, and you can also still pull down facts from before and see if you're in conflict with them or if everything works. If you can still do a fast forward, right, rather than a merge commit, and on it goes. And then when you're like, hey, I like my facts, they're all clean and they're pretty and I've rebased them and everything like that, then you could say go and now. I don't think you want to make that transparent to a user. But from a diagnostic standpoint for engineers like us, it would be really fun to be able to do that on the device. And then I do think you could enable that functionality for the users. You just wouldn't. Most people don't understand Git, so they're not going to understand this, right? But you could make it useful, which I think is kind of cool. You have like temporary facts, like trial facts, even locally. And then if you decide you want to change your facts, you're like, no, and then you're like, okay, and then you send it up.
Yeah.
No, Jeff, why not? Real situation, a scheduling app. You have a lot of employees and you're scheduling in time. And you start moving all these things. Every step in between is temporary. Totally. Then you say, okay, I try this, try that. Okay, now my scheduling, I'm happy with that. Save.
Yeah, what I like about this too. No, sorry, Jan, keep going.
No, and at the moment that you press save, then the whole scheduling, all the facts will be transmitted. But all the intermediate states, while you were shifting and doing, they are useless for other people. So I think that would be a nice application of what you're saying.
Yeah, I think too, you could also, oh no, I hope I didn't lose it. I had an insight and I think it just derailed. But with you mentioned the scheduling and the ability to do all this stuff. So, I know what I was going to say. I like that this also keeps you in the fact modeling world. So you're not having to create this static system where you're doing, because that's what I've had in mind too. It's like, well, and I know I'm going to have to integrate with some static systems. So thank God for, Outbox. That's going to be coming in really handy. But you could basically, there it goes again. Wow, what's wrong with me this morning? Anyway, I know what it is. You're using the same paradigm, right? You're still in the Factstore, whatever factual database kind of an approach. You could even do this actually from a server, as long as you had a way to say, that you could create like a session and say, for this session, these facts are temporary and they're not actually going to, or something like that. And then when you're done, you could rebase them, and they say, okay, now these are being committed to the real, the real thing. And maybe there's some different ways. You might want different tables or flags or something like that to flag them as part of a fact building session, if you will. But this could be really helpful, because otherwise a lot of times I'm looking at the transaction pattern and I'm like, this is great, but I also don't want to just smatter it everywhere just to be able to build things.
Yeah. So it would be a transaction that you build temporarily rather than physically in the model, but just in time. You're just So it's like you've got the persistent fact store on the device, and then you've got like an in-memory fact store sitting on top of it, and something it's like kind of a read through. And then when you create your facts, you're creating them in memory, but they're not being written through.
And I wouldn't even necessarily say in memory. I would say in a contained spot, which could actually be also in your it could be in your central database server if you wanted it to be, right? That should be transparent, I guess is what I'm saying. If you want it to be persistent, then you maybe don't want it in memory, right? You want it stored, but you just don't want it, actually merged in with your other fact, your trunk, if you will, right? Your main fact stream. So this gets interesting. It starts to open up some interesting ideas, I think. Yeah. And I think the other thought on that is we're horrible at this as engineers, at least most of us, is when we hear transaction, we conflate business transaction with database transaction. They're not the same thing. And I think in this case, I was struggling with this in my mind. I'm like, there I go again, transaction in here, and you model it this way. It's business process transaction. It shouldn't just be a way to capture what we used to call as database transactions. And this approach could actually be a better way to accomplish that. Yeah, right?
That's true.
Yeah. No, this is really helpful.
Jeff, but I think you still need the transaction pattern in the end.
Oh yeah, you need it.
All the intermediate states, you don't need them. But the final state is still a collection of facts.
Absolutely. That's right.
And all these facts, they are transmitted, but not necessarily at the same time. You transmit them, but that doesn't mean that they arrive at another client. Oh yeah. So you still need the transaction pattern, I think.
Right. I think the smell there to watch out for is, are you using the transaction pattern to make it like a traditional database transaction, or are you using it to model a business transaction? I think that's the difference that I had in mind. You definitely want the pattern, but the time to use it is, I'm modeling this, like in the examples in the book, like I'm capturing the state of these order lines into this shipping manifest or into this thing, right? That absolutely, that's a business transaction. So yeah, there you absolutely need it. I think I won't be the first one who starts to go down that well-worn mental path, because I'm still shedding my old everything's in RDBMS ways. And, after 25 years of recovery, I'm still falling back into it sometimes. So just good reminder that transactions does not equal transactions.
Yeah.
All the time.
Yeah, indeed. And one of the other well-worn paths that people start to go down when they start to read this stuff is modeling states as mutable properties. And so as we kind of wrap up the mutable property discussion and pave the way for the next chapter, when you can model something as an actual business event, do so. Don't just simply capture the fact that this event happened as a mutable state, so or mutable property. So the state that an invoice has been paid. Oh, I'm going to set the invoice paid field. I'm going to set that date at which that payment was received or whatever. They're you're taking the solution that you have used in the past of just updating a column in a database to represent that something has happened, and now you're saying, oh, this is how you update columns in a database in this world, so I'll use that. Yeah, that's there's better ways. The workflow patterns, start to get into that. We already talked about transaction. You mentioned Outbox. Unfortunately, we don't have enough time to go into Outbox, but it's one of those things that crops up over and over again, just like period. But yeah, in the next chapter, we're going to get into how you model state machines using these historical facts. At least I think that is our next discussion. I will confirm that real quick, and others can confirm that for me as well, since my phone is not working properly. And yes, that is what we're getting into. Well, no, actually, that is.
Isn't it query inversions?
Yeah, we're getting into the query inversions. So, I think I'm getting confused. I'm running a different book club internally, and I think I'm getting confused about what's coming up.
And we may want more sessions on the patterns too, you know, because there's some really rich stuff in there, and yeah, especially when you start getting into outbox and queues and the communication patterns and how they start to connect. It's intriguing.
Mm-hmm.
I'm interested in how to call an API once and not twice, for example.
Yep.
This hashing you mentioned in the book, it's very interesting. I never saw before it.
Yeah. Outbox get you as close as the mathematics says is possible. But there's no way to make sure that well, I would say the way that you phrased it there, that you call an API once. What you want to ensure is that the recipient has received the message once, and if there's an error, then you don't know whether the message was received or not. So that's why it's really impossible to make sure that the message is received once and only once. It's basically incumbent upon the recipient to make sure that happens. They have to be an active participant in the duplicate detection in order to make that happen. But we can try. We can get close. And the outbox pattern is basically the best try that I can offer you. I think it would be beneficial to spend some time specifically on that pattern. So I think it makes sense as we get into chapter 12 to really talk about that. So as we approach that chapter, we'll see if we've got enough time during that chapter to really give it the due that it needs, or if we need to have an additional meeting after that.
Okay.
Okay.
Awesome. Thanks so much for your time, Michael. Really appreciate it.
Yeah, thank you.